we go right here. So this x is by itself. It's not, there's nothing added or subtracted to it. So if x were 0, then this factor would be 0. So for the first one, we have 0. The multiplicity is 1, and that's an odd number. So that means it's going to cross. For the next factor, this one right here, the 0 is 2. The multiplicity is also 2. That's just a coincidence. And so we know it's going to be tangent, okay, or touch. So we go ahead and draw the, again, simple sketch. 1, 2, 3. So I put 2 right there. And so we sketch the 0, the 2, and you take the outermost points. There's only 2 here, so there's only 2 to choose from, and that's where you draw your end behavior. Okay, so on the left one, I'm going to go up. On the right one, I'm going to go down. Okay, and then in between, remember, the graph is not going to touch or cross through any other x value other than 0 and 2. So what does the multiplicity tell me right here? That at 0 it's going to cross, and that at 2 it's going to be tangent. So at 0 it's going to cross, and then at some point it's going to turn back up, and then it's going to be tangent. Okay, so it looks something like that. Again, this piece is not too accurate because I'm just doing a rough sketch. Graphing calculator gives you the better picture. But you need to be able to do this part by hand, and then just confirm with the graphing calculator. Okay, so take a look and compare the two graphs. The one we drew by hand and then the one on decimals, pretty close. First thing we're going to do here, though, is look at the turning points. So there's a turning point right here, 1, and there's a turning point right here, 2. So 2 turning points. Well, the degree of this polynomial is 3, right? X cubed. So the formula is x minus 1, n minus 1, so it's 3 minus 1, which is 2, and that's what we got, 2 turning points. This one has a it has a local max right here. Let me just erase this part. It has a local max right here. The value is 0, okay, and it has a local min right here. The value is negative 1.185. It has no global max or min because the ends of this graph go on up forever and down forever. So no local max, no global max, no global min. Okay, so we're going to first figure out what the leading term is, and in this one we have an x right here and an x cubed right here, and y cubed because of this 3. So this is an x cubed and an x, and then there's a negative out here. So this means, let me change the color, negative times x cubed. Now this is not the whole polynomial, but this just gives you the leading term. So this would be negative x to the 4th. Okay, with that we know that the ends of the polynomial both go down. Why? Because the degree is even and the a is negative. Okay, so both go down. So now for the zeros, you take the first factor and ask yourself what makes that factor a 0 if x was 1. Take the opposite of negative 1, so that would be 1. The power of this factor is 1, the degree up here is 1, so multiplicity is 1, so that's odd, so that means it's going to cross. The 0 here, x plus 2, for x plus 2 would be negative 2. That multiplicity is 3, so that means that it's odd, so it's also going to cross. Okay, so with that, let's go ahead and draw a very rough sketch. So I've got negative 2, I've got 2. Okay, and this is y. So 1 and negative 2. So those are my only two x-intercepts. Those are the only two contacts that the function has with the x-axis. Only in those two places, okay, nowhere else. And they're both crossing. Okay, so it's going to go on the ends, it's going to go down and then down. Okay, so in between, all we know is that it's crossing, right? So it could do some funny curve up here that we don't know about, but it's going to just cross through. I suspect that it's going to, up here, it's going to do some like curving, maybe like that, but we won't know until we use Desmos, okay? Okay, so with a degree 4, the formula says n, oops, let me use a marker here. The formula is n minus 1. Degree is 4, so it has that many turning points, 3. And you might say, wait, but I only see one up here, right? Up here. But if we look closer, let me see if I could zoom in here and I'll zoom back out. This is considered one turning point, and then it stops there, kind of like the cubic function, and then it changes direction. So that's 2 right there. So that's 2 there and 1 up there, so that gives you 3. Okay. As far as local and global max and min, this one has a global max up here. The value is 8.543. It has no global min because it goes down forever. And then let's see what else. Yeah, that's pretty much it. No local. Well, I guess this could be also considered local if we're looking at just that section. Okay, so let me just rectify something here. Switch something up. The turning points, even though right here there is a change in direction, like it's turning this way and then stops like a cubic function, we consider, go back, we consider this one the turning point, the one up here. So the 3 tells me the maximum number. It could have less than that, so 1 is fine. The 2 right here are just changes in directions, but they're not really turning points. They just change direction, but it's still going up as you go to the left. Let's see. This has only a global max, no global min, and that's it. So for 9 through 11, the last 3 problems, you just have to graph them or sketch the graph, and that's it. They don't ask you to state anything, just sketch it, but we need to find the leading term. So right here I've got x squared times x, so that's going to give me x to the 3rd, which gives me the end behavior. On the left it's going to go down, and on the right it's going to go up. Okay? The zeros, well, for the first factor, the 0 is 0. Its multiplicity is 2, so that's even, which tells me that it's going to be tangent. And then for the second factor, this one right here, the 0 is 2. The multiplicity is 1, so that's an odd number, so it's going to cross. Okay, so we go ahead and draw our so this is x and y, okay, and I know it's going to go through 0 and through 2, and then, sorry about that. And then the end behaviors, I know that it's going to come down like this, and it's going to go out this way, and it's going to cross through the 2, so that's how I know that I'm going to go through the 2, curve back up at some point, and then bounce off the 0 and continue my way. So this is it's a rough sketch of what it would look like. Okay? So the leading term for number 10 you get from multiplying x, and x, and then there's a negative in the front, so that's a negative x cubed. Just open the door here. So negative x cubed is the leading term. Whoops, sorry, lost the page. There it is. Negative x cubed. So that tells me that the end behavior is on the left it's going to go up, on the right it's going to come down. Let me erase this down here. The zeros are negative 1, 2, and 3 that I get from here. Negative 1, 2, and 3. The multiplicity of each of those is 1, so that means it's odd. So all of them have a cross, cross, cross. Draw your x and y. 1, 2, 3, 4. 1, 2. Okay, change the color. So negative 1, 2. Hello. All right, sorry about that. Let's see. So it's going to go through each of the x-intercepts. It's going to cross through, and I know that the endpoints on the left, it's coming in from the top like this. On the right, it's coming down. And remember, you always choose the x-intercepts that are the two outermost ones. Okay, and so let's continue. So it's gonna, at some point, it has to curve up so that it crosses through the 2, and then it has to curve down so that it crosses through the 3. Now this point up here and this point down here, I would, to get a more accurate, well, the y-intercept I could plug in the x, make it a 0, and I know that this here is negative 6, so I don't need a graphing calculator for that. But sometimes it keeps going down and then it curves back up later, so I don't know that until I get a graphing calculator. But for our homework purposes, this is enough. But again, you can verify with Desmos to get a more accurate picture. Okay, number 11, the last problem. We have, for the leading term, I've got to look at x, x squared, and x. When I multiply those three together, x, x squared, and x, I get x to the 4th. So then that tells me that the end point, the end behavior is up on the left and up on the right, because the degree is even and the leading term, the leading coefficient is positive, the a is positive. For zeros, I take a look at the first factor, and what makes that one 0 is 0. The multiplicity is 1, so that's an odd. 1 is an odd number, so then that means it's going to cross. Then I go to the next one right here, the x plus 2. The 0 for that is negative 2. Its multiplicity is 2, because that's the degree up here. That's even, so I know that it's going to be tangent. And then the last factor over here is x minus 1, so that's going to be a 1. The degree is 1, so that's an odd number. It's going to cross. So we're going to graph, just do a simple sketch. So negative 1, negative 2, negative 3, and 1, 2. Again, notice I just label the x-axis because the y, the numbers get really big really fast, or really negative, like really low really fast, so I just leave it blank. I'm going to go ahead and plot the 3 zeros, so 0, negative 2, and 1. So the outermost zeros are this one and this one, so this is where I'm going to draw the end behaviors off of this one and this one. So remember, it goes up, up, so on the left it's going to go up, on the right it's going to go, oops, sorry, on the right, oops, I dropped the pen, on the right it's going to go up. It's at negative 2, it's tangent. So what does that mean? Okay, so that means it's going to cross through 0. Then at some point it has to, it's going to cross through 0. At some point it has to come down, right? It has to come down. It's going to touch off on negative 2 and go back up. So something like that. And again, you could always input the equation into Desmos to get a more accurate picture. But for a test or a quiz, if you can give me something like this, what's on the screen, perfect.